Okay, people, these are the solutions to projectiles launched at an angle. All right, the problem will not ask you to find the initial over and up speed, but that is the first thing that you should do. So, oh shoot, I have different colors. All right, I'm going to make red horizontal. So the orange vector here, the over part of the speed, is going to be 75 cosine of 60, which is 37.5 meters per second. And the vertical part is going to be 75 sine of 60, which is 64.95. Check your work. 60 degrees is bigger than 45, so the up velocity should be bigger than the over velocity. Okay. And then get out your aggressions, cross out that 75 so you don't accidentally use it for any other calculations. Okay. And then rocket is fired towards an 11-meter high wall located 27 meters away. By how much does the rocket clear the top of the wall? So what the question is asking for is, what is this distance here? Which means we're going to have to find where the rocket is here, which is a vertical position, and then subtract 11 from it to see how much the gap was. All right, so I'm going to pause the video, set up my horizontal and vertical Sudoku. You do the same, and then we'll check back. Okay, so this is horizontal and vertical Sudoku. Hope that makes sense. Hope that's what you got. And then looking at this, you can see that we have more information horizontally. So that's how we're going to get the time. And then portal to the other dimension, but time is the same in both. Okay, but yeah, hopefully that makes sense. You see that we don't know y final, but we do know x final. So that's a hint. Let's start with the horizontal and see where we go from there. Okay, so position function, sorry, that's a t plus at squared over 2. Acceleration is 0. So 27 meters is our final location. Didn't have a head start. My initial speed was 37.5 times t, and that gives us a t of little under, 72% of a second, 0.72 seconds. That time is the same because time doesn't have direction. And now we're ready to start looking at vertical. And we want the output of the function. It started on the ground, heading up at 65 meters per second. It did that for 72 seconds, but gravity pulled it down at 9.8 meters per second squared. So this is, I don't have the sub numbers calculated, but hopefully you get the same thing. 44.2 meters. That is not the final answer. That is how high the projectile is. So this coordinate right here is over 27 up 44.2. I really want to reinforce that this is not a parabola because it's because of position versus time. This is a position versus position. This is a picture of the motion, not a graph like we did in the first unit. So what's hidden is this is our x, this is our y, and the time is 0.72. Okay, so what we want to know is what's the gap. So the gap is going to be 44.2 because that's how high it is, minus 11. So if this is like a goalpost, it cleared the goalpost by a lot, 33.2 meters. That's huge. Oh, because it's a rocket. It's not a football. Okay, that is question 31. Okay, this is another good question because it's not, it's a little bit more abstract. It makes you think a little bit harder. So we have a fire hose ejecting water at a speed of 25 meters per second. Assuming the water behaves like a projectile, so they're just saying there's no air resistance. We can use all of our physics Sudoku equations on it. What is this distance so that we can hit the highest possible fire? So that's a little bit tricky. So what does highest possible fire mean? That means that this location right here is your max height. And you want to be far enough away, right, so that it's safe for the firefighters, etc. But basically, that's just part of the story. So we want to know, hey, let's figure out, not quite sure where we're going to go from here, but we know that the highest point is the max height. What is always true at max height? Vy equals 0. Not total speed, but just Vy. Okay. And then no matter what the problem asks, you need to do your how much over and how much up is it going. So this is going to be 25 cos of 35 degrees, which is 20.5 meters per second. And this is going to be 25 sine of 35 degrees, which is 14.34. Sorry, my fours always get goofy on the tablet. All right. So again, 35 is under 45 degrees, so our horizontal speed is bigger than our vertical speed. So set up your horizontal and vertical Sudoku, and then we'll check back. Okay, so again, max height means Vy equals 0. I haven't said this yet, I don't think, but V is constant. So that's always going to be true. This is always going to be the same as that. So since what we know is something about velocity in the y direction, we're going to use our vertical Sudoku. And we want to know when the vertical speed is 0. I had an initial speed of 14.34, and I'm losing speed at 9.8 meters per second on the way up, and I'm going to gain it at that rate on the way back down. This gives you a time of 1.46 seconds. That's the time at the peak. Be careful that on a test problem, you might find time at the peak and then time at some other time. So you want to make sure that you're aligning, like this second column is only true at 1.46. So if you wanted to find when it hit the ground, you'd have to set up a third column for when y was 0, right? Y equals 0 and Vy equals 0 not happening at the same time. So those need their own columns to organize the information. Okay, so this is 1.46 seconds. And what do we want to know? Oh, we want to know how far it has traveled. So that means horizontal position function. Oh, let's do this in red. X equals x naught plus v naught t, because the acceleration is 0. And I'm looking for x. I did not have a head start. My horizontal speed was 20.5 meters per second. And I did that for 1.46 seconds. And so it is, they're probably trying to make nice numbers for you, about 30 meters even. Okay, so that's a little, it's kind of like you're working backwards. Oh, we forgot to cross that out. Okay. That's how far horizontally the water has gone when it's at max height. So if the water has gone that far, then that means move the fire truck back that distance so that the max height happens at the building. Okay. I think that's the answer to the question. I don't think we care about anything else there. All right, so that was nice little, different unknowns for you. Okay, 67. A golfer stands on the ground and we have a vertical location, and if the ball leaves a club with this speed and this angle, determine the time that the ball hits the green. All right, so again, the first thing you want to do is find your V0 X, which is 46 coastline 35, which is 37.68. And then find your V0 Y, which is 46 sine of 35, which is 26.4. Okay, and then say I hate traffic in DC, or I hate the long lunch line, whatever it is you want to get at your regressions, you're never going to use that 46. Okay, you know the drill by now. Set up your Sudoku, and then we will check in. Okay, so started with no horizontal head start on the ground. We already figured out the two initial speeds. No forces left and right, gravity up and down. And then if you look at the diagram, the information that you had about the time that you cared about was, we have no idea how far over it went, but we know it went up 5.5 meters. And this, just assume that the horizontal works out, right? That's what you know. So let's find out when the projectile was 5.5 meters high, which it means I know more about the vertical. So you're going to do your vertical column. So the output of the function is 5.5. I started on the ground, heading up at 26.4 T. Gravity's pulling me down at 9.8 meters per second squared. Okay, so it has been a while since we've had to use quad solve. Let's get it in the correct form. 0 on this side, minus 5.5, plus 26.4 T, minus 4.9 T squared. So this, including the minus sign, that's your A term. That's your B term. Including the minus sign, that's your C term. And you're going to get 2 times 0.217 and 5.17. Okay, I can see from the answers. This one's kind of tricky because usually, like for collisions, you're going to pick the earlier time, right? The 2 cars crash, boom, it's over. That didn't really happen. But if you look at this picture, the 2 times it's going to, and that's not a very nice parabola. The 2 times it's at 5.5 once the ball is on the way up. So that's clearly not landing on the green. If it was a problem like, somebody launches one of Miss Groppy's rockets in class, and the rocket inside and the rocket hits, my ceiling, then it could be on the way up. But if it's landing on my lab bench, then it clearly is on the way down. So we want, in this case, the later time. This is the earlier time, it's at that spot. Actually, I should have drawn it like this. Earlier time at that spot, later time it's at that spot, because it's on the way down. So we're going to, in this case, circle the later time. So that's a good question too. Lots of really deep thinking and not so much plug and chug in this homework set. So I hope that went well for you, and I will see you in class.